Right, today we move to Z test for the case 2. Right, for case 2, the distribution is unknown. Okay. Right, and the distribution unknown mean the question never mentioned is this a normal distribution, right? And the population variance given, and the last one will be n is large, right? So when n is large, right, if n is large, right, so that we can apply CLT to do this question. So when you need to apply CLT and you need to form your distribution, right, and same things, if you want to find the Z value, you will use the same formula. Right, and you will use this to find the Z value, and once you've done this, then you compare to the significant level that asking for, right? So then once you compare the significant level to check is it the values is inside the critical region or not. If not in the critical region, you will accept H naught. If in the critical region, you will reject H naught. As simple like that. Okay, so we go for question 5. Right, question 5. The manager of a large hospital states that the mean age of patients at the hospital is 45 years because of random sample of 100 patients at the hospital given mean age of 48.4 years. Assuming that the population standard deviation is 18.0 years, test at the 5% level of significance. Whether the manager's statement should be accepted, state clearly the not an alternative hypothesis. Right. So this question did not mention this is a normal distribution, did not mention what kind of distribution, and variance given or not. Yes, standard deviation given, right, and n given. Okay, and n is equal to 100, more than 30, so that you can apply CLT directly. Okay, so before we start, we need to state the hypothesis statement first. Okay, the hypothesis. First one, mu equal to 45. Okay, and the alternative mu, whether the statement should be acceptable or not, I mean is it a true or not, right? So is it true or not mean equal or not equal to 45. Okay, so you can state your parameter. Okay, this is your parameter. Once you have the parameter, you may direct go to find the Z value. Okay, so the Z value will be equal to the outcome that you found minus the claims and divided by this. Okay, so once you have this Z value, once you calculate, this one will be something like 1.8888. Okay, so for 5% significant level, you know that in your question is a equal or not equal is a two-tailed test. Two-tailed test means each end will be 2.5%. Each tail, right, will be 2.5%. So what you're going to find is, you will find Pz smaller than Z is equal to 0.975. So you will get the critical value is 1.96, right? So once you get the 1.96, you can directly do like that. Z is equal to 1.888 is smaller than 1.96. Okay, so positive compared to the positive side, right? So if this situation, okay, you can confirm that the mean that you found is not in the critical region. So if not in the critical region, what is the statement? So your statement is reject H1. Okay, so in favor of H0. Okay, so once you have this, you can state your statement. If in favor of H0 means, so at a 5% significant level, okay, the manager statement that the mean age is 45 years is supported. Okay, so you can have a similar statement, and this is not the this is the approximate statement that you need to write, okay, in order to answer the question. So the first statement is a general statement. Once you have the general statement, you should write the statement that according to the context. Please remember that. Okay, so this is for the case 2. Okay, for case 3. For case 3, the scenario is case 3. The scenario is variance unknown. Okay, n is large. How large? N will be larger equal to 30. Okay, if this happen, you can apply CLT, but because the variance is unknown, you need to use the unbiased estimate of variance, right, to find the unbiased estimate variance. Okay, the formula, still remember? The formula is s squared equal to 1 over n minus 1 sum of x squared minus sum of x squared over n. Okay, so the unbiased estimate to find the variance. So that once you have the variance, other things is the same. You can form your parameter. Okay, so this is the s squared over n. Okay, and after you have this parameter, you can find your z value. Same things. Right. So the process is the same. Just for case 3, you don't have the variance. You have to estimate, okay, the variance from the raw data. Okay, normally they will give you raw data. Either they give you the individual data, or they will give you something like sum of x, sum of x square, something like that. So you need to calculate from the raw data for the unbiased estimate. Okay, so we proceed to the next question. Next question will be question 6. Question 6. The manufacturer of certain type of light bulb claims that the average lifetime of the firm light bulb is 1000 hours. A consumer group thinks that the manufacturer is overstating the lifetime of the light bulbs and tests a random sample of 64 bulbs, recording the life x in hours of each bulb. Okay, the results are summarized as below. Sum of x equal to this, sum of x squared given to this. Okay, so you can see that this question never mentioned is normal distribution. Okay, and the variance did not mention. So you need to unbiased estimate the variance. But the mean given, I mean the benchmark average 1000. And you need to calculate also the unbiased mean for your further calculation purpose. Okay, so now we continue and see how to calculate this. Okay, part A. Part 1. Calculate the sample mean. Alright, so if you want to calculate sample mean as normal, if you want to calculate sample mean, will be the mean will be equal to sum of x over n. So it's equal to 6319910.4 over 64. Right, so you have a 998.6 for part 1. Right, so for part 2, calculate the unbiased estimate of standard deviation of the lifetime of this type of light bulbs. Okay, so because they give you raw data, so you need to do the unbiased estimate. So 1 over 64 minus 1, 63, and 638.24061 minus 63910.4 square, 64, right? So once you calculate this, you should get a 49.77. Alright, so the S will be equal to square root of 49.77, about 7.04 standard deviation. Okay, so so this one is 7.05, something like that. 7.05. Okay, so you can simplify your answer become 7.05 or 7 point. Okay, so this is your answer. Okay, part 3. Is there evidence? Is there evidence at 10% level the manufacturer is overstating the lifetime of light bulbs produced by the firm? Right, so for this part, you need to run the test. Before you run the test, you set your hypothesis. Okay, H1. Okay, so if the oversetting mean actually they will produce lesser oversetting, actually they will produce lesser. Okay, so in this situation, this is your hypothesis that you need to form. Okay, so once you have done this, you should form your parameter. So your parameter, you may get the exact value from above, or if you can't get the exact value, you may consider to get a longer decimal at below. Maximum 5 don't go more than 5 lah. Okay, so maximum 5 decimal is okay already lah. more than 5, the walking will become tedious, right? So over 64. Okay, so in this situation, if you continue to calculate, right, so we're going to calculate z value. So the z value will be equal to just now the mean that given the calculate above 998.6, okay, minus 1000 the clamps, then over square root of 49.77, okay, over 64. Okay, once you can calculate this directly from the top, and you should get z equal to negative 1.587, 1.5. Okay, so now once you have this negative 1.587, you need to compare the significant level. So significant level is 10%. 10% one tail, the lower tail. So 10% will be, if you refer to the table, 10% will be 0.9, 1.8282. So you are at the negative side because lesser. So this one is smaller than negative 1.282. Okay, so if smaller mean this is in the critical region. If in the critical region mean you reject hash note, okay, in favor of hash 1. This is a general statement. Okay, so once you have this general statement, so what should you do? Okay, so after this general statement, you should answer according to context. So at a 10% significant level, right? Uh, the material is, so the question is asking you that the overstating lifetime. So what should you say? The claims that, okay, the manufacturer is overstating the lifetime of light bulbs produced by the firm is supported, right? So means actually they already overstate the lifetime of the light bulbs. Okay, so you can say the claims that the manufacturer is overstating the lifetime of the light bulbs produced by the firm is supported, right? So this is for part 3. Okay, for part 4, state whether it was necessary to use center limit theorem in your answer in part 3. Okay, if it was, state what point it was necessary to use that. Okay. Okay, so need or not need? Right, so the questions you already applied at the beginning actually, because n larger equal to 30, so you need to apply CLT. In the exam you don't write CLT, you should write center limit theorem. Okay, so because the distribution is unknown, or you can say it's not normal. Okay, so that the center limit theorem tells you that in this situation the distribution mean lifetimes of the box is approximate normal. Okay, so this is needed in specific the distribution of the test statistics as stated in part 3, right? So simple like that. As summary, you can say n larger or equal to 30, and because the question never mentioned the distribution is unknown, so when you apply standard limit theorems, okay, the distribution is approximate normal distribution, so this will need to specify the distribution of the test statistics as stated in part 3. Okay, so general like that, so you can restructure your sentence. Okay, main thing is you answer whether you need to use, so when you need to use, and after you use what happened. Okay, so this is the things for part 4, right? Okay. Okay, now we will move to question 7. Question 7. Okay.